Hello, dear aspirants. Myself, your mentor, Aadityaamlan Panda, and I am here to discuss with you the question which we had posted in the community. The question was from chemistry, and it told that which of these two compounds are having high vapor pressure at a particular temperature. To our left side, we have p-nitrophenol, and to our right side, we have m-nitrophenol. Now, the first ever mistake which people do when they see this kind of question is that they consider these two as individual molecule than considering them as a bunch of compound and lots of molecule present together in a single container. So never ever do assume them as a single molecule, rather assume them as the entire fluid phase of the compound itself. Now in the following slides, what we would be doing is that we'll be considering each one of them separately and would be discussing why and how the vapor pressure is getting affected and how are we going to compare them. So let's get started. Now taking the case of p-nitrophenol, as I told you, you have to consider the entire molecule itself with lots of entire compound itself with lots of molecule present together. Now, as you can see, the hydrogen here is bonded to an electronegative atom, and here we have another electronegative atom. So these will lead to the formation of hydrogen bond between these two, as nitrogen is a very small electronegative atom and oxygen also is a very small electronegative atom. So these are the hydrogen bonds that will develop between them. Now these hydrogen bonds, they would do what? Is that they will increase the intermolecular forces of attraction, because these are intermolecular forces. These are intermolecular hydrogen bonding, and this will increase the intermolecular forces of attraction. And hence, due to this intensive intermolecular hydrogen bonding and the intermolecular force of attraction increasing, it will love its liquid phase over its vapor phase. It will love to be in the liquid phase itself and will not go to its vapor phase. जबकि इसकी इंट्रामोलिकुलर फोर्स ऑफ अट्रैक्शन बहुत ज्यादा होती है, इसको अपनी लिक्विड फेज ज्यादा पसंद है अपने वेपर फेज के मुकाबले. इन सबको साथ में रहना पसंद है. They love to interact with each other than being contained in themselves, and that is the reason which is forcing them to be in the liquid phase. So this is the case of p-nitrophenol. Now shifting to m-nitrophenol. Now again, we have to consider the entire compound rather than taking the molecule itself. So this is the compound, as you can see here, instead of they getting attached to some other molecule, like this hydrogen is again attached to an electronegative atom, and we have lots of other electronegative atom like nitrogen all over. And now since this OH and this O has an H with it, and this H wants to get bonded to an electronegative atom, this will prefer its own electronegative atom present in the same molecule itself to get attached. And why is it so? Here it looks that these two are closer, but in the entire molecule, there are lots of molecules in the same compound, and that is why these ones will love intramolecular hydrogen bonding over intermolecular hydrogen bonding. And that is the reason why these will be contained in themselves than interacting with each other. Now, since this is intramolecular, and if it is intramolecular, the intermolecular hydrogen bonding would be reduced. It will be reduced because it loves interacting intramolecularly than intermolecularly. Now, due to this intensive intramolecular hydrogen bonding, there is low intermolecular force of attraction, and due to this low intermolecular force of attraction, it loves moving to its vapor phase than being in its liquid phase. Why? Because in liquid phase, intermolecular force of attraction is much higher than the vapor phase. जबकि इसकी vapor phase में intermolecular force of attraction कम होने की जरूरत है, और यहाँ पे intramolecular hydrogen bonding की वजह से इसकी intermolecular force of attraction कम होती है, तो इसको वेपर फेज ज्यादा पसंद है इसके लिक्विड फेज के मुकाबले. Now moving to our question, which asked us to solve it at a particular temperature. Now at a particular temperature, what all conclusions can we draw? The first thing is that the one which loves vapor phase will have higher vapor pressure. This is of course because it will form vapors first, and that is the reason why it will have higher vapor pressure if we consider some random particular temperature. Now, understanding this in terms of boiling point, we can also get it this way, that since boiling point is a temperature at which the vapor pressure is equal to the atmospheric pressure, and that is why the one which is more vapor prone or which loves getting into the vapor phase quickly will have lower boiling point, because इसको vapor phase जाना ज्यादा पसंद है ना, तो एक टेम्परेचर बढ़ने से ये जल्दी अपने वेपर फेज में शिफ्ट हो जाएगी, जिसके वजह से वो टेम्परेचर जिसमें इसकी वेपर प्रेशर एटमॉस्फेरिक प्रेशर के साथ बराबर होगी वो बहुत जल्दी आ जाएगी. दैट इज द रीजन व्हाई इट हैज लोअर बॉइलिंग पॉइंट, एंड दैट इज द रीजन व्हाई it has a higher vapor pressure at a particular temperature, because इसको जल्दी अपने वेपर फेज में जाना होता है और इसलिए वो एक पर्टिकुलर टेम्परेचर में इसकी वेपर प्रेशर हाई होगी ताकि वो जल्दी से जल्दी अपने वेपर प्रेशर को एटमॉस्फेरिक प्रेशर से बराबर कर ले. और इस तरह से बॉइलिंग पॉइंट के टर्म्स पर the one which has a higher vapor pressure at a particular temperature, that one, and it is more vapor prone, and that one will have a lower boiling point. Now, what our question asked was that at a particular temperature, which of these two will be having a higher vapor pressure? Now, since B or M-nitrophenol loves the vapor phase due to intramolecular hydrogen bonding as compared to P-nitrophenol, which undergoes intramolecular hydrogen bonding. And that is the reason why the M-nitrophenol loving vapor phase will have a higher vapor pressure at a particular temperature. At a single temperature, it will have a higher vapor pressure. And if we move further, the answer to this question is B, because it likes to get bonded intramolecularly than intermolecularly. And so it wants to get straight vapor phase first, and that is the reason why B, that is M-nitrophenol, will have a higher vapor pressure at a particular temperature. Hope your queries are clear in this question. Yet if you have some doubts, you are welcomed to put them in the comment box. So thank you for watching this video. Have a great day ahead.